As we learned last time, one of the ways of solving quadratics is by using factoring. We shove everything over to one side so it equals 0. So we can use that zero factor property by factoring this addition problem into a multiplication problem. Now, last time we did it with binomials. Doing trinomials is a little trickier, but still not too bad. Okay, so here's our first example. You'll notice this doesn't equal 0. So we're going to subtract the 60 over. And now we have something that equals 0. Now, the factoring is a little easier when this a term, this first coefficient, is 1. Okay? Because we know it's going to take this form right here. X plus something else. The other thing we know is that these have to multiply to negative 60, and these have to add to 17. So what we can do is we can break down the factors of 60, negative 60, until we find something that adds to 17. So I'm going to break this down real quick. We've got 1 and 60. Again, I like to do 2 next. So 2 and 30. Is it divisible by 3? Yes. So 3 and 20. Is it divisible by 4? I have to think a little more on that one. 4 and 15. Is it divisible by 5? Yes. 5 and 12. Is it divisible by 6? Yes. 6 and 10. 7? No. 8? No. 9? No. And then we get back around to 10 and 6. So these are all of the factors. Now, be careful. This is negative 60. So instead of these adding to 17, we basically need them to subtract to 17. So do these subtract to 17? No. Do these subtract to 17? No. Do these subtract to 17? Yes. What do our signs have to be to make that happen? 20 minus 3. Now, again, be careful. 5 and 12 would add to 17, but since it's negative, we need one of these to be negative. So x minus 3, x plus 20 equals 0. And then we can set those factors equal to 0. X minus 3 equals 0. X plus 20 equals 0. X equals 3. X equals negative 20. So these are our two possible values for x. Now, whenever a does not equal 1, whenever that first coefficient does not equal 1, we don't know that it's going to have just x and x here. And it makes everything just a little more complicated. So here's the trick that we're going to use. So what we're going to do is we're going to multiply the first coefficient by the last coefficient, our a times our c. Okay, so 2 times negative 15, that gets us negative 30. And technically, we need to also have the x squared there. And we're going to do the same thing. We're going to see what adds to x here. So we've got 1x. So 1 and 30, 2 and 15, 3 and 10, 4. I don't think it's divisible by that. And then we got 5 and 6. So how are we going to add these up and make them equal 1? Now remember, it's negative, so they're basically going to have to subtract this time. So let's see. These don't subtract to 1. These don't. But 6 minus 5. So 6x minus 5x equals 1x. So what I'm going to do, I'm going to rewrite this expression right here. I'm going to go ahead and erase this. Now, what I want you to notice is that I haven't changed the value of this expression. because negative 5x plus 6x still equals 1x. So I cheated by changing it a little bit, but we're still mathematically sound because I haven't changed the value. Now what we do, we're going to factor by grouping. We're going to find the greatest common factor of these two and the greatest common factor of these two. So the greatest common factor of these two is x. The greatest common factor of these two is 3. And if you've done everything correct, these factors should be the same. Okay? So what we're going to do is we're going to say, oh, well, 2x minus 5 got distributed to two things. It got distributed to the x and the 3. So if we distributed this out, it would give us this. Well, look there. We've got it factored out. So now all we have to do is set these factors equal to 0. So 2x equals 5, x equals 5 halves, x equals negative 3. All right. One more example where a doesn't equal 1. Okay, so we're going to take 6 times 3. It's going to be 18x squared. So 1 and 18, 2 and 9, 3 and 6. Now, this time, since it's positive, we actually are trying to add to 19. Okay, so which one adds to 19? Well, looks like it's this one. So I'm going to take this, going to split up those two terms. But again, we haven't cheated really because this is the same value as this. By the way, the order of these two don't matter. You will get the same solution regardless, okay? So what's the common factor here? Well, it's x. So 6x plus 1. What's the common factor here? Well, it's 3. So 6x plus 1. We know we've done this right because these are the same. So what have we done? We've taken 6x plus 1, and it's been distributed to both of these. So that's what would happen here. 6x plus 1 would be distributed to x. 6x plus 1 would be distributed to 3. So we know we factored that correctly. Set it equal to 0. So x equals negative 1/6, and x equals negative 3.